Hey, it's DK again. Today we're going to do a program, maybe two programs, where we light off some LEDs, okay? Well, maybe one LED to start off with, then we'll light off a couple others. And then we'll build on this program to do some other things. But first, let me just for grins, all right? Let me just for grins, get out of screen sharing so you can see that I'm actually on my iMac, right? So what I'm going to go ahead and do is I'm going to start my screen sharing. I'm going to find my IP address for my wireless connection to my Raspberry Pi, which has been powered on. And I'm going to go ahead and connect to it. I'm going to type in my password, my secret password. All right, I'm going to go ahead and connect that. And there it is. There's my window for FXCE on my Raspberry Pi. So today we're just going to go ahead and write a small program. So I'll just go ahead and do that. Let's go to Applications. I'm going to go and use my GVIM. There we go. There's GVIM. I'm going to increase this size a little bit if that's okay with you. All right, move this over just a tad. All right, so reduce the size just a little bit. Sorry about that. Okay, so first thing I'm going to do is save the program. So I'm going to go File, Save As, and I want to save it on my desktop in the Program folder. So I'm going to go to Desktop, Programs. And I've got all these programs there. So what do I want to call this? I guess I'll call it LED GPIO 1.c. Okay. So that's my first program to light off a GPIO pin and light off an LED. So, that's pretty descriptive. So I'll save that. So you notice that I'm saving it to LED GPIO 1.c, which is great. It's probably in my progs folder. Let's see. Double click on my progs. LED GPIO 1.c. Terrific. Okay, it's there. Fine. So I'll just go ahead and close that. All right, the first thing is, remember, I'm going to insert. So I'm going to type in the I for insert. You see the insert icon at the lower left. Double slash ENGR 121 section 3. And I am DK, and this assignment, well, I'll just call it LED GPIO intro. Okay. And so this will be program name. And I know my program name is right up here, okay, which is LED GPIO 1.c. Okay, so that's my program name. So I know where I am when I'm writing my program. And then I go ahead and do a pound include stdio.h, right? Standard H, standard. So you can actually put a space in there if you like. Sometimes some people don't like spaces. And then I'll also put a pound include wiringPi.h. Okay, so we need that wiringPi, remember. So need wiringPi include file for specific instructions for GPIO. All right, general purpose input output. All right, actually we'll just put out wiringPi.h so that will make it all right, so now I'm going to go ahead and start my program. And then Dr. Mayhew likes it like this. Okay, like that. And I am going to start writing my program. The first thing I'm going to do is go ahead and set up my wiringPi. In other words, initiate the wiringPi to set up my 40-pin connector. So I'm going to say wiringPi setup. There we go. So what that does is, of course, initiates, sets up, I should say, sets up the I/O pins and instructions for wiringPi. So remember, when you do these programs, right, to pay close attention to the capital letters and the small letters that I use. So in the #include statement for wiringPi, I have wiringPi P being capitalized. And here we have wiringPi where P and S are capitalized. Okay, so what I'm going to do, okay, is set it up so that I have, so I'm going to attach my LED and its resistor, which is in your, the diagram is provided in your what's called a fritzing diagram. Okay, so it's wiring diagram, and I'll show you that fritzing diagram here in just a sec. All right, so I'm going to choose GPIO 0, which is pin number 11. All right, so let me just bring that over into the screen so you can see what that looks like. Oops, come on. Box of candies in the way. All right, so I'm going to choose GPIO 0. All right, so let me go ahead and annotate that so you can see what that looks like. Oval, kind of a big oval, but all right. GPIO 0, there we go. Pin number 11, okay? So that's what I'm going to use, all right? So we'll go ahead and take this back. So I'm going to say the first thing I'm going to have to do is set it up, okay? So I'm going to do a GPIO. No, so what I'm going to do is make a comment that says use GPIO 0 pin 11 to turn on LED. Okay, so I'll go ahead and do that. So the first thing I'm going to do is light up my LED, and the way I light up my LED is first thing I have to do is GPIO setup. I have to set up my GPIO setup, so that's not the instruction. So I'm just gonna I am going to say put a comment. So I'm gonna say set up my my 40 pin connector, GPIO connector pin 11 to be an output. Okay, so you're gonna have to like set it up to be an output, and the way you do that is with this instruction: pin mode. In this case, it's GPIO 0 that we want. So 0, 0. And we want that to be an output. Notice the capital letters on the output there, okay? Semicolon. Okay, don't forget these semicolons, all right? These semicolons, they're really important. So what I did there is set up pin number 0, GPIO pin number 0, which corresponds to physical pin 11. Let me show you that diagram just so that you have it. Sorry about that. Let me get this going so that you can see it. There it is right there. Okay, so what I want you to do is set up GPIO 0, which is physical pin number 11 here, which is the 1, 2, 3, 4, 5, 6 pin on the left hand side, to be an output. So you can configure that as an output. You can configure these things as inputs, but you know, for now we'll just configure them as outputs, right? All right. Now that that's configured, we can start to write the program. All right. So I'm going to turn on the LED. All right. So if I want to turn on the LED, if I want to turn on the LED, I'll do a digital write 0, and I'll make that go high. So give it the high voltage. The high voltage is actually only 3.3 volts. What that does, of course, is turn on the, I put the on in capital letters, on GPIO to 3.3 volts, or high voltage. Okay. And then I'm also going to give it a delay. Now you can do a delay in a couple of ways. So I'm going to show you 2 ways to do a delay. I'm going to do my for loop, right? Actually, if I want to do my for loop, I have to like include some kind of integer here. So int I. So I'm having an integer I, which is a variable, and of course this is all bugabooed now, but that's okay. And I'm going to say for I is equal to 1 to I less than 1,000. I'm going to let I increment. All right. So I'm going to put a little wait state in there. Okay. So this is just waiting, or delay function. All right. And I'm just going to close this. All right, so that's one way to do it. Okay. And then if I want to turn off the digital GPIO 0, I'll just do a digital write pin mode GPIO 0, and I'll put a low. Okay, so that turns off the LED. What that does is turn off the LED. Okay, so go ahead and do that. Because I'm sending a low voltage. Alright, so that's one way to do it. I turned on the LED, waited for my for loop to go through 1,000 iterations, and then turned off the LED. Maybe 1,000's not enough, you know, maybe I'll put 2,000 in there, whatever, okay? You play around with that number. The other way to do it is, I'm going to go ahead and, after I turn off the LED, I'm going to delay this thing. So I can put a delay, and I can put like 2,000 milliseconds in there, okay? So what that is delay 2,000 milliseconds, all right? Delay is great. And then I can turn on the LED again, so digital write. I'm going to turn on the LED, comma, high. Okay, so I turn on the LED, and then I can digital delay it. I don't know, delay by how many seconds should I? 5 seconds, all right, 5,000 milliseconds. Okay, so that's delay by 5,000 milliseconds. And then I will turn it off. So I'll go digital write pin 0, GPIO 0, low. And that should be the end of my program, okay? I turned off my LEDs, everything's fine. I'm going to go ahead and print to my screen that I'm done. So I'm going to print, print F /n/n, put 2 spaces in there, I'm done. And then put a little Hawaiian in there, all pow. And /n/n, and close bracket. All right, so now I'm done with my program. What I did was turn on the LED. I'll put a right curly bracket to finish off my program. By the way, this should be in main. So this is my program, and it kind of looks all bugabooed. So what I'm going to do is I'm going to go ahead and save it and then bring it back out so you can see what that looks like. All right, so I'm going to go escape, write that thing. Oh, not quit, write. And I'm going to go ahead and quit. Okay, so I quit. So my program should be in progs. So let's take a look at the program. There's my GPIO 1.c. And there's my program. All right, so let's take a look at the program and see what it's doing. Let's close this thing right there. All right, so we have my program there. That's me, wiringPi.h with a capital P, int main, integer I, wiringPi setup, semicolon. Then I do a pin mode 0 output. Then I do a digital write 0, which is a high. Turn on the GPIO to 3.3 volts or high voltage. Now I'm going to do a for loop, iterative delay. Okay, so I'm going to delay it for 1,000 loops. All right, that's just a delay function. And then after I delay it, go through 1,000 iterations of this little loop. I'm going to say, all right, I'm going to turn it off now. Turn off the LED. That's my digital write 0 low, and my delay. There's my digital write digital write high again. Okay, to turn on the LED again. Now this time I'm going to delay it by 5 seconds, which is 5,000 milliseconds, and then I'm going to turn off my LED. And then once I turn off my LED, I'm just going to say, hey, I'm done. Okay, so there's a extra semicolon, so I'm just going to, oops. Shoot, let me bring that up. Sometimes the interface just doesn't work right, so yeah, I know that. Okay, edit anyways. So here's my program. So I'm going to go down, go down, go down. Okay, it looks weird, okay, because of the way the thing is. So if you really want to see what the program looks like, I'm just going to go ahead and quit out of here. And there's another way to display the program that I'll show you that won't have this problem when you're using VNC. So I just went to my my shell here, all right, my terminal. I'm going to do an ls to figure out where I am. I'm here, so I'm going to do an ls home. Figure out where I am there. I'm going to go to me, so cd me. Figure out where I am. And I want to go to desktop, so cd desktop. Figure out where I am. Progs, okay, so I want to go to progs, cd progs. Figure out what's in there, and there's my LED on. Don't do this thing, okay? Do the LED on.c. So in other words, if I just want to see what's in there, I'll do a cat space LED on.c, okay? Actually, what program was it that I was running? Was it LED on or LED on 1? I think it was LED on 1, right? LED. Oh, no, it was LED. Well, let's try on, see what's there. Ah, yeah, so this is the program. This is great. I'm going to extend it up so you can see what this looks like. There's my program. So this is a good way to just print out the program, do a cat LED on. Or whatever the name of the program is. I turned it on. Well, I really don't want to do a digital write while I'm oh, this is a wrong program, so let's not do that. So I'll do a ls cat led on 1.c. Okay, I think that's the program. Yeah, that's the, no, that's not the program either. Oh, led GPIO 1. So cat led GPIO 1.c. Okay, so I just print that out. So there it is. So that's my program, and I write at 0, write to GPIO 0 high, which turns it on. I wait for 1000 iterations on the for loop, and then I turn it off. Turn off GPIO 0, wait 2 seconds, and then turn on the LED again. In fact, I have an error here, right? So that should be GPIO 0. So we go ahead and fix that. All right, so let's go ahead and fix that. I'll exit. I'll go ahead and fix that. Edit anyway. Right in here, okay? There we go. All right, so I should be able to compile it now. So let's try to compile it. So again, I look for my program, cd home, ls cd me, ls cd desktop, and then cd progs. Oh. And then I have led GPIO 1.c. Okay, so I'll go ahead and do that. But remember, to compile it, you need to do it to sudo, right? So sudo led GPIO 1.c, and I need to use the wiring and then capital PI library. Oh, I need to put its GCC in front of all of this. GCC. Yep. So I should read sudo gcc led GPIO 1.c minus L wiringPi. There's an error, so apparently I forgot a semicolon. All right, so it says, hey, expect a semicolon. So let's see what my program is. Let's see what it's actually doing. So let's shrink this down, and let's see what it's doing. So I'm going to go ahead and go to gvim, file open, my desktop, programs, led GPIO, yeah, okay, edit anyways, fine. Where was the error? Digital zeros, there's right high. Okay, so I do need a semicolon right there, all right? So I just need to include a semicolon there. All right. And are there any semicolons elsewhere that's missing? There's a semicolon, semicolon. No other semicolons missing that I see. So I'm going to go ahead and save this and see if it'll run now. Okay. Try this again. Here's my terminal. Let's see if it'll compile. Hey, it compiled. All right. And now, in order to run the program, you do a sudo /a.out. Right, and then it'll actually run the program. It's running, and it stopped. Okay, you saw the delay, right? All right, so what does a circuit look like? Well, let's take a look at the fritzing circuit so you can see what the fritzing circuit might look like. So I'm going to bring up the file for you so you can see what that looks like. So what fritzing is just a way to show some wiring up diagrams. Okay, so this is fritzing, all right? All right, so this is my fritzing program. It helps me, you know, design up some things. All right, so file, I need open recent files, yellow, green, yellow. Is that it? No, it's not, but it's basically the same thing. All right, so I want to use GPIO 0. I want to go from this GPIO 0 pin to connect up to this little part here. So what I'm going to do, okay, what I'm going to do is go ahead and erase stuff that I don't need. So I'm going to take this and erase that. Delete that. I'm going to take the yellow and delete that. And I'm going to delete this since I don't need it. Delete this. Delete that. Delete that. Oops. Delete this little wire. I don't need that. I don't need this wire. I don't need this wire anymore. Okay, I don't need this. I don't need this node anymore. And I don't need this node anymore. All right, so what I need to do is I need to connect that. Well, I don't need this wire either here. All right, so what I'm going to do is I'm going to go from GPIO pin 11, and I can actually connect directly to my resistor, which will be here, okay? And then notice these are all connected together in a row. And then this guy right here is connected like this, okay, all in a row here. So I want to connect my LED. I'm going to go ahead and rotate this around. Rotate it by, actually, I don't need to do that. I'm going to take this thing and just connect it. I need to rotate this around. No, connect it like that, okay? So I go from GPIO pin 11 to GPIO pin 11 to a 220 ohm resistor, which I will provide to you, then to an LED to light that off, and the long pin, the long pin is here. This is the long pin. Okay, this is the anode, the long pin, as you can see. And then the short pin is the cathode, which goes to ground. Now you want to hook this up to pin number 14, which is your, which is not your ground pin. Your pin, yeah, pin number 14 is your ground pin. All right. And when you do that, you won't be using these GPIO pins. You'll be you won't be using this one. You won't be using this one. You'll be just using the GPIO 11. When that goes high, your LED lights up. When GPIO 0 goes low, your LED does not light up. Right? Okay. So that's really the lab today, experience today. And then next time what we'll do is maybe add another color, and then the way we're going to do that is create what are called functions, and we can create multiple colors turning on and off using functions. But today, this is all we're going to do. All right. Okay.